All right, so try to make things a little tougher. I'm now solving an inequality with fractions in it. But recall when we solved equations, our trick is to find the LCD, multiply both sides by it, and clear the fractions. So when I look at this problem, the LCD seems to be 4. So I'm going to take this side and multiply it by 4. And I'm going to take this side and multiply it by 4. I'm multiplying both sides by a positive, so I don't have to worry about flip-flopping any signs. So that's really nice. We're just doing the golden rule. Whatever you do to one side, do to the other. Distributing here, we get a 2x minus 4 greater than or equal to. Distributing here, we get an x plus 12. So subtracting x from both sides and adding 4, it looks like we get x is greater than or equal to 16. All right, and so there's basically our solution. And in terms of an inequality, if we let me graph a number line. So we have 16. We're allowed to be equal to it, and then we're greater than it. So we're talking about everything to the right of that. So we're talking 16, comma, infinity, brackets, and infinity. So there would be the solution to that first one. Again, to visualize that, let me come over here and let's go ahead and just see that on our Desmos. So here is the graph of 1/2 x minus 1. It's kind of in that greenish color. And here's the graph of 1/4 x plus 3. And so we see, right, let me change colors so we can kind of contrast those. Let me put that in red. All right, so we can see that the graph of 1/4 x plus 3 is actually above, right, 1/2 x minus 1. So it's not solving it in this region, but as I move over, right, there's 16, and at 16, the graph of 1/2 x minus 1 is now above the graph of 1/4 x plus 3. So basically we can see that we are verified. All right, we did the right job. Our algebra is right. We're good to go. So the next one, again, let me start by clearing fractions. 3, 5, 4, and 10. Well, looking at an LCD for all that, that's pretty tough. I know it's 20, 30. I think it's 60. So I'm going to multiply both sides over here by 60. And whatever I do to one side, I do to the other. I don't think there's anything lower than that. Yeah. All right. And so distributing, we end up with 20x. This is 120 divided by 5, or think of it this way. 5 into 60 is 12, times 2 is 24. 4 into 60 is 15, times 3 is 45. 10 into 60 is 6, times 7 is 42. So let me just double check on my math. 10, 4, 15, 45, 5, 12, 24, 3. Yep, so we got it. So fractions are cleared. I don't worry about the inequality here because we never multiplied or divided by a negative. It was a positive 60. So moving some things around, I'll subtract 45x from both sides and add 24. So again, I'm not multiplying or dividing. We end up with a negative 25x on this side. Cancels, cancels, and it looks like we have a 66 on that side. So now, right, be careful. I am truly dividing by a negative 25. And so when we figure this out, this is now x is greater than or equal to negative 65 over 25, which is roughly about negative 2 and 16 over 25. Okay? So we're talking about x is greater than that. We're allowed to be equal to, so we've got negative 66 over 25, comma infinity, and that would be our solution set. So again, we can verify that with our Desmos. So when I graph the first function, here's what 1/3 x, it's, let me go back to the origin, right? So kind of in that blackish color is 1/3 x plus 25, minus 2/5. And then when I go graph, oops, what did I do there? When I go graph the other side, let me put that in another color so we can truly compare, right? There it is in red. And we can see that the black graph, this guy, actually sits above the red graph, right around that x-intercept. Of course, we know that to be negative 66 over 25, or negative 2 and 16/25. And then what happens is once we pass that point, the graph of 1/3 x minus 2/5, right, or excuse me, the graph of 3x plus 7/10 in red is above the graph of 1/3 x minus 2/5. So we do see that that inequality does hold true. This graph is less than that graph. and they're equal at that. So again, we are good to go. Our algebra matches up what we have. So the good news is solving linear inequalities, it's the same way we solved equalities all year long. You just keep playing the golden rule. Whatever you do to one side, you do the exact same thing to the other. The only nuance that's different from equalities is when you multiply or divide by a negative, right? When you do that, like I did here or I did here, you accompany that with a direction change. You flip-flop your inequality because we're introducing, as I showed you here, we're introducing the concept of oppositeness. And when I introduce oppositeness, I've relocated myself on the number line. You can literally, again, see yourself flipping. All right, so that's that. So there's your linear inequalities. We'll take a look at even some tougher ones in the next video coming soon.